Hello everyone, I am PhD student Zhang Keji from Kyushu University, Japan. Today my title is Influence of Shear Affected Zone due to punching in tensile characteristics of steel plates. Nowadays, because of their low-cost punch processed steel plates are widely used in auto production. Please look at the schema. This is the punched round hole, and in this depth from the hole inner surface, there is a region where the material be affected by the punching process, and the region is called the shear affected zone, SAZ. In the SAZ, the most seductive thing is that there is a large deformation occurs in SAZ when punching, so that the SAZ has large work hardening. Comparing with base material, too many positive and negative changes by shear process for tensile characteristics exist in the SAZ, like work hardening, grain refinement, hardness increase, like roughness, micro crack, tensile residual stress. So it is difficult to make clear the specific effect of the SAZ on tensile characteristics. Dallow et al. Has researched about shear processed plane specimen by using dual-phase DP steel and got this conclusion. A crack initiates in the steel during tensile loading. The crack reduces steel's elongation. So in this study, we want to know what is the crack and how does the crack affect steel. For the experiment, we used the whole specimens with and without SAZ to do a tensile check test. The material is RDP steel, which Mr. Dallow et al. Used, and titanium precipitation hardened pH steel, which is also one kind of HSLA steel like DP. But compared with DP steel, pH steel has very small hardening like this graph and low Kc. The test material are called DP6, DP8, pH6, and pH8 because they have tensile stress of 590 megapascal and 780 megapascal grade. The DP6 and DP8 are composed by ferrite and martensite. The pH6 and pH8 are composed by ferrite and perlite, and also titanium carbide exists. The specimens are hot rolled steel plates like this shape. For the central round hole, we have two methods to produce it. For the ideal steel, the hole was shaped by drilling and hole inner surface polishing, so there is no SAZ exists. For the punched steel, the hole was shaped by only punching, so that there was SAZ exists and the depth is about 1 millimeter. Then the tensile test and the fracture surface observation is held as this schema. Here's the result. First, the engineering stress and stroke curve of ideal and punched specimens. The most seductive thing of this curve is that the pH8 punched material shows brittle fracture. We also took photo when loading of the punched material at the 3.85 millimeter stroke, this line. At the pH8 punched material, we can see that the necking is concentrating in a very narrow range at the tensile direction. So we can see that the pH8 has a material quality that can easily to cause strain localization. Here are the SEM pictures of fracture surfaces of ideal and punched specimens. First, the ideal specimens are divided into two parts. From the whole inner surface, the failure starts with a square failure area, like the photograph B1, and finally is the shear area, like the photograph C. Both of the areas are composed by dimple. And then punched specimens. pH 8 punched steel is divided into three parts. First is the slant fracture area, like the photograph A, and then is the square fracture area, like the photograph B2, and finally is the shear lip, like the photograph C. A and C are composed by dimple, but B2 is considered as quasi-cleavage because it shows cleavage fracture without a river pattern. The other punched materials than pH 8 are also divided into three parts, and like the pH 8 punched material, except the square failure area is like the photograph B1 instead of B2. Here I want to introduce the slant fracture area in punched steels. The direction of slant fracture area, which is the initial crack, is inclined to the tensile direction, like the following schema. This is the slant fracture area. Slant fracture area is considered as caused by shear stress, so we call it shear crack. And then I want to introduce the stress zone in shear crack tip. Stress zone is a ditch formed by yielding and blunting of crack tip. In this study, in these pictures, we can see that in DP6, DP8, pH 6 punched specimen failure surface, there is a stress zone exists between shear crack and the square failure area, and there is no stress zone in pH 8 punched material. So we can see that the shear crack tip of DP6, DP8, pH 6 punched material has blunted and yielded sufficiently like this schema, and the stress zone can be seen. The shear crack tip of pH 8 punched material is still sharp like this. Now we can discuss about the cause of square failure fracture errors. The square fracture errors in pH 8 punched steel is considered as shaped by brittle fracture due to quasi-cleavage, because the shear crack tip keeps sharp until final fracture. The square failure area in punched DP6, DP8, and pH 6 steel are considered as shaped by stable fracture due to the indentation, growth, coalescence of void, because the shear crack tip had blunted after shear crack shape. Now we discuss about the influence of the crack lines. As the former research about the hole expansion, the hole expandability of pH steel is better than DP steel. But in this study, the tensile characteristics of the punched specimen of the DP steel is better than pH steel. The reason is considered as the crack lines. In the former research, there is only a shear crack exists, which is a short crack with the about SCZ length. In this study, the shear crack is also SCZ length, but the effective crack is not only includes the shear crack, but also includes the hole diameter, because the sizes of shear crack and hole diameter meets the condition to be seen as a long crack like this schema. In this study, is this condition. Then the behavior of the material follows Kc. The Kc of pH is lower than EP. So it should be attention that for punch process steel, the superiority of the steel depends on its effective crash length. This is conclusion. By comparing whole processed steel under tensile loading with or without SCZ, we obtain that shear crack initiates in the SCZ. For punched steels with the material quality easy to cause strain localization like the KH8 steel, the shear crack tip is sharp and cause brittle fracture behavior. For punch processed steel, the superiority of the steel depends on its effective crack length. That's all. Thank you.
Thank you.